Welcome dear viewers to the another informative video on demonstrating the discriminatory power of dissolution test. See, nowadays all the regulators are asking to develop a product specific dissolution test. Then the clinically relevant specifications, and that's why the dissolution test becomes very critical. Demonstrating discriminatory power means your method is able to discriminate between the good batches and the bad batches. Good batches are those which are bioequivalent, and bad batches are those which may be bioinequivalent or which may be inequivalent to the bio batch. In other words, dissolution is a performance testing as we know, and if the dissolution test is not discriminating between the batches, then it will be difficult to prove that the commercial production is sending the batches into the market which are safe and efficacious. So for bioequivalence perspective, safety and efficacy perspective, dissolution becomes very important test. And nowadays demonstrating the discriminatory power for the dissolution test is very important, and many of the applicants get the queries from regulatory authorities for the discriminatory power of dissolution testing. So in this video we are going to learn about the demonstration of the discriminatory power. So what are the steps? See, in the research and development, the scientists know the product, how their product is behaving, how the reference product is behaving into the dissolution, and the main factor for stopping the research work is having the similar dissolution of test formulation with the reference formulation. In other words, if the formulator gets the similar dissolution of the test formulation with the reference product, then the research works stops, and then the bioequivalence is required to be tested. So the best practice for demonstrating the discriminatory power is have your data of all the batches in your hand and then check when and which batches failed in dissolution, which batches were faster than the innovator, which batches were slower than the innovator. So you will get the critical parameters or critical material attributes or critical process parameters which affects the dissolution. So the step in demonstrating the power of dissolution, discriminatory power of dissolution test is to identify and list the CMAs and CPPs of the product affecting the dissolution. Critical material attributes. These might be of the drug substance or the critical excipients. Example of drug substances, if you consider BCS class 1 and 3, these are highly soluble, and that's why the PSD may not affect the dissolution. Very rarely it may happen that though the API is BCS 1 or 3 and still particle size is playing a role. But in many of the cases, for highly soluble APIs, dissolution will not be affected by the particle size of the API. If your formulation contains BCS class 2 or 4 drug, these are poorly soluble and thus the particle size may affect the dissolution. Then at that time you have to use or you should use the drug substance which is having the particle size out of the specification. For example, you have finalized PSD of API, that is D90 is less than 30 micron, and you have finalized that. So take the batch with API of D90 of 60 micron and see its impact onto the dissolution. And if you get the discrimination or if you fail into the specification, then you can say that the dissolution test is discriminatory. It has discriminatory power to discriminate the batches made with the out of specification of PSD of API. Then crystalline and amorphous API. If you have finalized amorphous API, then you can check the batch for dissolution with crystalline API and see whether the dissolution is affected by the crystalline API. Sometimes some processes are used to make the API amorphous, and many of the times the API becomes crystalline during process or on stability. So this is required to be demonstrated for the formulations which are made by the solid amorphous or solid amorphous solid dispersions technology. Then going to the next point, that is CMAs of excipients. Here viscosity of the binder like HPC, HPMC binders are used. Then binder grades are based on the viscosity. So those CMAs you can take into consideration and you can make the batches. Like you are finalizing the HPMC with 3 CPS grade. So take 6 CPS grade and see whether the dissolution catch that change. Then capsule shell made up of hard gelatin or HPMC capsule shells. Generally, if the test formulation is made up of gelatin capsule shell, you can try with HPMC capsule shell and check whether your dissolution profile gets changed. But it is not recommended because in the production run or commercial production, this may not happen as there is a CGMP and quality management system. Then excipient level. So many of the regulatory authorities are suggesting to use 10 to 20% change to the finalized specified values. This is regarding the excipient level. The regulatory authorities are saying that you can make the change of 10 to 20% to the finalized or specified values or excipient levels and then check the dissolution. Example I have taken as a binder, level is 4%, minus 20% will become 3.2% as lower level and plus 20% will become as 4.8 level, 4.8% as higher level. So you can try this. ER pellet coat weight gain can be varied to show discrimination. If you are working on a pellet formulation with extended release coat, so you increase the coat by around 20% to the finalized value and then check the dissolution. Then excipient position. Sometimes the excipient position can be varied to have understanding on the impact. So intragranular disintegrant and extragranular disintegrant, percent or level of disintegrant in the intra and extra part. Then coming to the critical process parameters. These are the parameters which affect the CQS. So CPPs of the manufacturing process can be varied. Granulation time for wet granulation or top spray granulation. Roller compaction force for roller compaction process. Lubrication time. Higher lubrication time may give you the hydrophobic granules, and that's why it may have impact on the compression and the DT and dissolution. Then tablet hardness. Compression force can be varied, which will give you the change in the hardness of the tablet. And hardness out of the range can be tested to get the understanding that whether the hardness is affecting the dissolution or not. Then for powder filled capsules, stamping force can be varied, and then dissolution can be performed. Make the batch with 10 to 20% change to the finalized specified values or ranges for the CMAs and CPPs. Then compare the dissolution results with target batch and the bad batch. So bad batch is the batch with intentional changes, and then you will know that whether the dissolution test is discriminatory or not. See, some challenges and limitations are there for discriminatory power demonstration. Formulations with BCS class 1 and 3 drug substances and with rapid dissolution are challenging for achieving the discriminatory dissolution. See, generally for BCS class and 1 and 3 molecules, the rapid dissolution is required. For example, you are giving a specification of 30 minutes or you are giving a specification of 15 minutes, and your disintegration time for the tablet or capsule is 2 to 3 minutes, then it becomes very difficult to work in the specified ranges like 10 to 20% on the CMAs and CPPs and then show the discriminatory power. So this is the challenge. If the dissolution specifications are too wide, then achieving the discriminatory dissolution becomes very difficult. So for the case 1, the formulations containing BCS class 1 and 3 drugs and immediate release type of formulations, you have to show your efforts for getting the discriminatory dissolution. You may not prove that your method is discriminatory, but still the regulators are interested to see your efforts and what efforts you have taken for the dissolution development and also to show the discriminatory power. Another one is if the dissolution specifications are too wide, then achieving the discriminatory dissolution become very difficult. Simple meaning of this sentence is that if the formulation shows 100% drug release in 15 minutes and you have given a Q point of 30 minutes of not less than 80 Q, that is 85%. So this means you have given a very wide specification, and that's why it becomes very difficult to prove the discriminatory power, because at 30 minutes whatever the batches you make, those batches will pass. So you have to set the meaningful specification of 15 minutes as per the current guidelines. So never go for a too wide type of specification, otherwise you will not get the discrimination. Then consider the commercial production batch variability and relate to the dissolution. The formulators or scientists, if they want to show the discriminatory power, sometimes irrelevant batches are taken and it is shown that the dissolution is showing the discriminatory power. But you should always consider the commercial production variability only. If your process of manufacturing is wet granulation and you take the batch with direct compression and then you are showing the discrimination, it is wrong and it should not be a practice, because in production you are not going to make a batch with direct compression. Then profile comparison versus Q point comparison. Generally it is observed that for showing the discriminatory power, the profile comparison is done and F2 is calculated. But in production or commercial run, profile will not be done and the batch will be released into the market based on the Q point. So if your Q point is 30 minutes and you are making the batch with profiling and it is going out of the F2 similarity, but still the batch will pass on the Q point. So in production run, that batch will not be rejected. So always consider the final specification. As the Q point dissolution is done on the commercial production batches, there are chances that all the batches will pass. So this is very critical. In research phase of the formulation development, many of the people or many of the scientists show the discriminatory power of the dissolution method by profile comparison, but they skip the point that in commercial run there will not be a profile comparison. For IR formulation specifically, there will be a Q point and it is a chance that in Q point all the batches will pass. So that time give the tight specifications to the formulation based on the bioequivalence batches, and then you can prove the discriminatory power of your dissolution method. 10% difference in the dissolution is considered as similar as per F2 calculations. So if you get the dissolution with difference in 10%, then it is difficult to show the discriminatory power. Also, if you work on 6 units and you show the discrimination that the dissolution method has a power to discriminate the batch, then it might be sometimes wrong, because from 6 unit the dissolution will go into S2 stage with 12 units in the commercial batches, and then if still it fails, it will go into S3 and there it will pass. So at S2 all batches will pass, and if any batch is there with little bit variability, if it is going to S3, there are more chances that that batch will pass. So always consider the S2 stage or always consider 12 unit data for showing the discriminatory power. Then some of the best practices are there. For making the batches, change one factor at a time to show the discrimination. Sometimes some people do this practice that they increase the binder and decrease the disintegrant and then they show the discrimination. So it should not happen, because it may be misleading. Do not delete or replace the excipient. Sometimes the disintegrant is replaced. So in production run, you are not going to make a batch without disintegrant. So consider the production scale, operations and total quality management, CGMP, and the batch will be manufactured as per the finalized formulation composition and the finalized process. So always consider the variability. Do not delete or replace the excipients. Do not change the manufacturing process to show discrimination. As I talked, if the process is with top spray or wet granulation with dissolving API and then spraying, or dissolving API into binder and then adding into the RMG, or sprayed onto the bed like in top spray. And if you are showing the discrimination by making the direct compression type of process, then it is misleading, because in production you are not going to make the batch with DC process. Then discrimination is to reject the bio-inequivalent batches in commercial production. Always use mild condition for dissolution, and the dissolution should not be under discriminatory or over discriminatory. See, dissolution is a very vast topic, and while giving the dissolution specification, while developing a dissolution method, many of the factors are involved. So always use the mild conditions. If you are using 75 RPM for paddle apparatus, then it is important to have the data with 50 RPM also and with 60 RPM also. At 75 RPM, if it is slightly more for the formulation, then it will be very difficult to achieve the discriminatory power with 75 RPM compared to 50 RPM or 60 RPM. Always consider the bioequivalence batch dissolution as a target dissolution. Then identify the factors critical to dissolution during the product development stage. So as I talked in the previous slides, always have the list of critical attributes for the dissolution and then go for showing or demonstrating the discriminatory power. So for this video, this was the information, and I hope this video may help you for making the batches for showing the discriminatory power. See, nowadays all the regulators are asking for dissolution method development and for demonstrating the discriminatory power. Almost all of the generic applicants get the query on dissolution for tightening the dissolution specifications and for showing the discriminatory power. If you are using a monograph method like USP monograph or other pharmacopoeial monograph methods, still you have to show the discriminatory power. Otherwise, you have to develop a specific method which is discriminatory and which can reject the bio-inequivalent batches. So this is regarding the discriminatory power for dissolution testing. I hope you might have taken a good understanding from these videos, and keep watching Pharma Learning in-depth channel videos. I am very happy to see the response from the viewers, and some viewers are also from the foreign countries. Kindly give me the suggestions for any topic which is related to the dissolution or other topics which you want to learn, so that I can make some efforts and come up with a video. Thank you for watching the video. Stay connected to Pharma Learning in-depth channel. Thank you.